Okay, so in our last video, we're going to try our last Lewis structure for nitrate. Okay, so at this point, we've already done ammonium in our first video, carbon dioxide in our second, and this is our last example, okay, nitrate. Okay, we're going to follow the same procedure. Okay, just total up the valence electrons, find our central atom, and then just make sure that all the atoms have an octet. We don't have any hydrogens here, so there's not going to be any of them that just follow the duet rule. We'll have just octets for every atom. Okay, so here are your elements. You have nitrogen, you have oxygen, you have one nitrogen, and nitrogen has 5 valence electrons. So that gives you a total of 5 valence electrons there. Okay, you have 3 oxygens. Oxygen has 6 valence electrons. So that gives you a total of 18. Okay, and again, this is an ion just like our first example, but this has a negative charge. So it's -1. Remember, negative charge means you have more electrons. -1, so that means you're going to have 1 more electron. So you're going to add 1 valence electron because you have a -1 charge. Okay, now total them up. That gives you 24 valence electrons. Okay, so this is the valence electrons that you have to work with, the electrons that you should account for in your molecule. All right, so let's start drawing our Lewis structure. I'm going to write the valence electrons here at the bottom so we can refer to them, and then just erase this part of our work. Okay. So again, you have a binary molecule. You have just nitrogen and oxygen. We'll put nitrogen in the middle. It's also our least electronegative element. So we'll put nitrogen in the middle, and we'll arrange our 3 oxygens around that nitrogen. Okay, so now remember, each covalent bond, each line represents 2 electrons, 2 shared electrons. We have three covalent bonds, so that's going to account for 6 of our valence electrons. So 2, 4, 6. Now we have to use up the other 18. All right, so I'm just going to start filling in lone pairs. So 2, 4, 6, 8, 10, 12, 14, 16. That's 18 valence electrons plus the 3 covalent bonds, so 18, 20, 22, 24. Okay, so we used up all 24 of our valence electrons. If you count the electrons around the oxygens, they all have 8. Got the covalent bond, that's 2, and then 3 lone pairs, 4, 6, 8. So all your oxygens have an octet. Does the nitrogen have an octet? No. You only have 3 electrons around that nitrogen, or 3 pairs of shared electrons, 3 covalent bonds. So you only have 6 electrons around the nitrogen. Somehow, you're going to need to come up with another pair of electrons for that nitrogen. So as I mentioned, when you don't have enough electrons to kind of just put lone pairs around your atoms to make an octet, that should kind of be a hint that you're going to need a double or a triple bond. All right, so I'm just going to take 1 pair of electrons from one of those oxygens and make a double bond. So I'll just pick that pair of electrons, and I'm going to make that a double bond. Okay, so there you go. Now you have a double bond around that oxygen, and this goes away. Okay, so now, does each atom have an octet? See this, the first oxygen with the double bond has 2, 4, 6, 8. Yes, it does. The second oxygen, 2, 4, 6, 8. That has an octet. The third oxygen, again, 2, 4, 6, 8. And then the nitrogen, the double bond, that's 2, 4. And then the other covalent bond, 6, 8. So each atom has an octet now. Now, did we use up our 24 valence electrons? Well, let's count them all up. Starting with the double bond. 2, 4, 6, 8 around that first oxygen. The next oxygen, that would be 10, 12, 14, 16. And then the last oxygen, 18, 20, 22, 24. Okay, so you've used up all 24 of your electrons. You've made sure that each atom has an octet. So each one meets the octet rule. So this is your Lewis structure. Okay, only one other thing, well, a couple of other things that we have to make sure we do. Because we randomly put that double bond on that oxygen, okay, we could have just as easily made the double bond on the second oxygen or on the third oxygen. So we have to draw something called a resonance structure. Okay, we have to show that that double bond could have been on the second oxygen and the third oxygen. So we're going to have to draw this Lewis structure 2 more times with the double bond shown on the other oxygens. Okay, so drawing it over again, put the double bond on the second oxygen, and completing all the lone pairs. Okay, 2, 4, 6, 8, 2, 4, 6, 8. Okay, so that double bond could have been at the top, or it could have been on the right side on the third oxygen. So we'll have to draw this Lewis structure one more time. Okay, nitrogen, double bond, oxygen, single bond, single bond. Okay, 2, 4, 6, 2, 4. And let me clean up that last piece. Okay, so, and 2, 4, 6. Okay, so we redrew that 2 other times, showing the double bond on each oxygen, because that double bond actually resonates. Okay, it could exist in any of those oxygens at any particular time, and we have to show that in our Lewis structure. Okay, now last thing, it's an ion. So with any ion, we're going to show that it's an ion by putting it in brackets and then showing our charge on the upper right hand corner. Okay, so this is our Lewis structure for nitrate. Okay, and this is how you do Lewis structures. You just, for our purposes, we're doing very simple ones. You know, all of them follow the octet rule for our purposes in this introductory chemistry class. Okay, we're just making sure each atom has an octet, and if it's hydrogen, each hydrogen has an octet. We use up all our valence electrons, and that's pretty much it. Okay, we'll see you next time.